All right, so these are Wikipedia pages. So this is the frequencies I was talking about when you pull a string. Okay. If you take a string that's tight at both ends and you pluck it, then it starts vibrating, right? And the sound that you're hearing is actually not just a single wave, but the sum of all these waves, right? And so you're listening to the superposition of all these different waves at the same time. They're being heard at the same time. Of course, the coefficients will be different. So in most cases, this will be the highest one, and this will be much smaller and smaller and smaller. It will get smaller and smaller as it goes. Right. And you can see here that the bass note is the slowest, right? As it goes higher, this is the fastest. Right? Now, on the other hand, let me show you the vibration of a drum. So here, let me see. Let's make it bigger. Oh, okay. So here, alpha 01, that's what I was calling as J01. Some people call it alpha 01, some people call it Z01. I don't know which one's the best. I'm just using one of them. And alpha 01 is the case where you have the zeroth Bessel function which has a non-zero value at 0, right? J0 has a non-zero value at 0. You see, wait, just a minute. These other ones. Oh, yeah, so these are 0 ones. Let's see. Yeah, so if you look at alpha 11, for example, you see that the middle one doesn't change at all because the Bessel function J1 it only has a 0 value. So when it goes up and down, this middle point doesn't change. So anything that has n equals to 1, see n equals to 1, those will have the 0th part staying there. On the other hand, these ones are n equals to 0, and J0 has a non-zero value, right? So the middle part will go up and down. Another thing I want to say is that when n is equal to 0, that's the case where the radial function is the constant one, because you have cosine 0 theta and sine 0 theta, right? You remember that? So that means that these functions with 0 on the n will be radially symmetric. So you only have the values that change radially. Okay? You get that?
So
Yeah.
top one is hitting it one stick in the middle. And
If you do that, yeah, if you hit the one point at the middle, that's what you're going to see.
and the second one is when you hit
Second
two
one,
stick,
yeah,
I'm
so
assuming.
yeah, so if you hit it exactly in the middle,
That's
then
the top one.
the vibrations that you'll see will be these ones. But if you go slightly off axis, then you're going to start seeing these ones. Yeah, with this one as well. Right? It'll be a superposition of all these different ones added together. Okay. And they can give you quite complex tones.
How do
yeah.
you control which mode you produce?
It's some of, you're hearing everything at the same time.
Oh,
It's this plus this plus this plus this plus this plus this. But the one with the lowest frequency is the one that has the highest amplitude. So you're hearing this the most, but then there are overtones. Some people call it harmonics, but harmonics is when they have good harmonic structure. So people just say overtones. So so you have some overtones that are generated by these ones. Okay. So that's what you see.
so it doesn't matter how you do, and you just change the volume. Right? Didn't change any tone.
So everything has a pitch. You know what a pitch is, right?
Yeah.
440 hertz is key of A.
Yeah.
And 808 is the one octave higher one,
Yeah.
right? So it depends on the value of C and L, the thing that we solved over there. But with that, you're going to have the fundamental frequency with a pitch. And you're going to hear something that's higher, but with smaller volume.
If there's an infinite dimensional vector space, and which one, everyone is a dimension, and could you change the direction of the vector, or?
I mean, okay, so these functions could be thought as individual vectors, and you're adding infinitely many of them, but
yeah,
there are two things that...
I mean, the rates of their combination, could you change it?
No, the coefficient will... The volume, which is the amplitude of each frequency, those will change. Yeah. So I want to say two things. One is that our ears can only hear up till 20 kilohertz. So even if you have higher frequencies beyond that, you're not going to hear them. Okay? And I'm pretty old, so I can only hear probably like 12 kilohertz or something. So I can hear even less. Okay? And also these volumes decay to zero quite fast, so you don't have like infinite frequency. That doesn't exist. Okay. Another thing I want to say is that you could actually think the opposite way when you learn this. So what I mean is that for a long time people were trying to make music using electronics. They still do now, right? But even when the computers were not too fancy in the 80s, when we didn't even have basic computers, well, maybe we did. Like when computers only had like a few kilobytes of memory, you had synthesizers like Yamaha DX7. And what it did was it would add different sine waves of pure pitch with different amplitude. You add them up, and you could add like 6 different ones and make sounds out of it. And what they did was, instead of recording a drum and then playing it back, they didn't have that much computer power back then. So instead of doing that, they would have these sine wave generators with these pitches, right? With the amplitude that you would get when you play a tom-tom. And you do that and you make it create the sound, and suddenly what do you have? You don't get the realistic tom-tom, but you get something quite pleasant. So that was like the birth of these, what do you call it, these synthesizer drum machines. So long time ago there were only acoustic drums, but at some point people are using this to create drums that made some nice sounds, and now they have EDM, electronic desktop music, and you go to, what's like the big festival, I've forgotten, dance music festival. You guys go to those? I thought you went to those places, no? All right. Well, anyways, so that's the birth of these synthesizer music. So you could do the opposite. Okay? You can. So nowadays, what people do is they come up with different models of an instrument, and make computers create sounds that mimic a real life situation, or even create something that's not physical but still make something that would make people to think that, oh, I'm hearing something that's circular, or something like a marimba or something there. So yeah, it's pretty cool, right? It's if you look at this one, you can kind of see that, oh, it is indeed like a sine wave, but that's like decaying, like 1 over square root of x. That's the intuition. If you can get this intuition, then you...
So the second number is k, right? Or n?
Yeah, second number is k. So the first number is what I called n. So alpha and k is the kth zero of the Bessel function of order n. Yeah, that's what we